Look at any standard model of the early universe, and you'll see a timeline where the first few 100 million years are mostly dark, empty. Then, in May 2025, a team of astrophysicists looked at a tiny patch of space and found an object that breaks that timeline entirely. They found MOM Z14. It's a galaxy detected by the James Webb Space Telescope, a machine built with specialized gold-coated hexagonal mirrors designed to capture light from the absolute edge of the observable universe. The light from MOM Z14 has been traveling for 13.53 billion years to reach those mirrors. That places it deep within the universe's infancy. We are seeing this galaxy exactly as it existed just 280 million years after the Big Bang. According to the physics we've relied on for decades, a galaxy like this simply shouldn't have had time to form yet. Finding a fully assembled, bright structure sitting right in the middle of a period we thought was dark and quiet means our basic assumptions about the universe's origins are flawed. For years, astrophysicists operated on a consensus. If any galaxies managed to coalesce in those first few 100 million years, they would be incredibly rare, be physically small, and extremely faint. MOM Z14 is none of those things. It is brilliantly bright, putting out enough energy to be classified by its discoverers as remarkably luminous. Before this discovery, the absolute limit of our vision was GNZ11, a distant galaxy found by the Hubble Space Telescope back in 2016. This timeline shows the shift. MOM Z14 pushes our cosmic horizon 100 million years earlier than GNZ11, and in the gap after the Big Bang, the math doesn't leave time for a structure to gather mass and ignite so brightly. This single data point contradicts decades of simulations, forcing astronomers to reconsider the entire timeline of how the first structures in our universe were assembled. To understand how we know this, we have to rely on a concept called look-back time. Light has a strict speed limit, so when we look at objects billions of light years away, we aren't seeing them as they are right now. We are looking directly into the deep past. Because that ancient light stretches as the universe expands, it shifts into the infrared spectrum. Webb's massive mirror segments are specifically designed to detect these exact infrared wavelengths. And what Webb is seeing is a period of space that was once completely choked by a dense, opaque fog of neutral hydrogen gas. We call the period when that fog finally cleared the reionization era. Reionization is a stage of cosmic evolution when neutral hydrogen began once again to ionize due to energy radiated by the earliest celestial objects, making the universe transparent. If you enjoy untangling the hidden mechanics of the early universe, make sure to hit subscribe so we can keep exploring these cosmic mysteries together. The intense radiation flooding out of MOM Z14 identifies it as a primary engine of reionization, actively burning through the neutral hydrogen fog to make the early universe transparent. Physically, this galaxy is tiny, only about 240 light-years across, making it roughly 1% the size of our Milky Way. Yet it is packed with an estimated 100 million solar masses of material. But mass isn't the real problem. The real problem is its chemistry. It shows an enriched metallicity. Metallicity refers to the abundance of elements heavier than hydrogen and helium in an astronomical object. Heavy metals are forged over millions of years inside a star's core and released when it explodes as a supernova. Apply that multi-generational life cycle to a universe only 280 million years old, and the math breaks down. There hasn't been enough time. For MOM Z14 to possess these heavy elements, it must have gone through a violently rapid period of star birth and death, a process so fast that current models of physics can't account for it. MOM Z14 represents a growing class of these impossible objects, joined by other recent discoveries like Glass Z13 and Pan Z14-1 that share the same extreme luminosity. This means the period we confidently labeled the Dark Ages was actually filled with massive luminous structures, assembling themselves at breakneck speeds. This animation illustrates the scale of the search. The James Webb Space Telescope found these anomalies by pointing its sensors at a patch of sky about 1.5 times the width of the full moon seen from Earth. When you realize that such a microscopic slice of space contains multiple fully formed early galaxies, the statistical implication is clear. The infant universe is densely populated with these objects. Astrophysicists are now forced to discard the accepted timelines. The textbooks outlining how and when galaxies gather mass, ignite, and mature have to be completely revised. With the timeline pushed back, the race is on. Astronomers are recalibrating their observations to hunt for the absolute first generation of stars to ever ignite. As those initial stars ignited within the primordial gas, they exposed a first generation of light that was intensely bright and chemically complex. Every time we engineer a sharper lens to look out into the dark, the universe answers with structures and timelines that outpace our best theories. We build the telescope, and space provides the mystery.